Hi everyone, in this video lecture we are going to understand that why do we need reinforcement learning to instill reasoning in LLMs. So basically we know that in LLMs we can use supervised fine tuning to induce a certain behavior into the LLM. But can we use the same supervised fine tuning technique to instill reasoning in it as well or not? The answer is that we cannot use supervised fine tuning directly to instill reasoning behavior in LLMs, though I'm saying that the DeepSeek team did use supervised fine tuning to instill reasoning behavior in smaller LLMs using supervised fine tuning, but that is a different story. Usually, you do not use supervised fine tuning to instill reasoning behavior into LLMs, you use reinforcement learning. So let's try to understand that why do supervised fine tuning why does supervised fine tuning not perform good for reasoning, though it can induce reasoning into an LLM, because we know that if we what is a supervised fine tuning, basically we give a prompt and the target response to the LLM to imitate. For example, if we are going to give a prompt, let me open paint, let me delete this one. Okay, go to hell. So if I have an LLM and I give this prompt to it, what is 2 plus 2, and the LLM might respond to me 4. Now, even though the answer is correct, this is not the way that we would ideally want the LLM response to our questions. We would ideally want it to greet the user and then give the answer in a very polite manner. So the ideal response would be, hello, how is your day? The answer to your question can be calculated using addition rule in mathematics, which says to add both the numbers. Thus, whatever we said, 2 plus 2 equals to 4. So the correct answer is 4. So this is the response, but this is the response that is more suitable. This is the response that we would like the LLM to give whenever a question like this is passed. So just like this is the prompt and this is the ideal response to it. We train the LLM on hundreds and thousands of such prompt response pairs, and eventually the LLM learns that in order to answer a question, it should ideally build this preamble, it should greet the user and use very polite words and basically work in a very step by step manner. So, this is the way that you ideally make the LLM behave in a certain way. We can use the same way, we can use supervised fine tuning to instill reasoning behavior in LLMs. So, for example, in this instance, you can see that we have a problem 17 into 4, and with supervised fine tuning, we are trying to make the LLM solve this equation step by step. The agent is going to understand that whenever it is put whenever it is asked a mathematical question, it should ideally try to answer it in a step by step fashion, but the agent does not understand that how do I actually reach the correct answer. If I by mistake did 17 into 3 instead of 17 into 4, the agent, instead of realizing that it made a mistake and correcting its mistake, it is going to continue in this step by step manner. Instead of using 68, it is going to do 17 into what is going to be the value 21. 1 2 3 ones are 3 3. So 17 into 3 is 51. Instead of using 68, it is going to use 51 here, and it is going to get the wrong value here, and it is confidently going to say that this is the correct answer to this problem without ever realizing that it made mistake in the step number 2, because it is just, because in supervised fine tuning it is just trained to imitate this step by step behavior. It does not know that this step by step behavior needs to be correct in each step so that the answer it eventually reaches is correct. If it made a mistake in step number 2, it is going to have repercussions in step number 3. It just knows that whenever a math problem is asked, I need to answer it in a step 1, step 2, step 3, step 4, step 5, 4 fashion, and I do not care if I made a mistake. In contrast to that, the reinforcement learning algorithm, if it encounters a mistake, for example, it did the step 1 incorrect, for example, if even if it had done the step 1 correctly, no, it has done the step, what I'm trying to say that in reinforcement learning what happens is that if the algorithm is trying to answer the question in a certain manner, but it realizes that it has made a mistake during its step, it has the capability to first identify that it has made a mistake, identify a mistake. Secondly, it can traverse back and it can correct the mistake it made. It can identify the mistake, identify the mistake, and it can correct a mistake. Whereas in supervised fine tuning, it cannot backtrack the mistake it made and it cannot correct the mistake. In reinforcement learning, we do some things that you are going to learn later on in this course that helps the algorithm to backtrack its wrongdoing and correct them. So this is the promise of reinforcement learning, that if the agent has made a mistake, it can identify its mistake and it can correct them. But do remember, at the end of the day, these are LLMs. They can still hesitate, they can still make mistake, and they can be confident on their mistakes. Remember, always remember, these LLMs are just picking the best possible token from a distribution of tokens. They do not understand what is happening. They do not have any consciousness. At least by 20th August 2026, they do not have consciousness. So I hope that you have understood the difference between supervised fine tuning and reinforcement learning, and why is supervised fine tuning not a very good idea to induce reasoning into large language models, and why is RL a better way to do so. We learned that in SFT it is basically trying to imitate the prompt response pair we provided to it. So for example, in this scenario, we provided this prompt to it and we provided this uh, response to it. This is the ideal response, and when it is going to be trained over hundreds and thousands of example for any given math problem, is going to try to solve it in a step-by-step fashion. It might correctly solve it, it might not correctly solve it. God knows what happens. What the difference between SFT and reinforcement learning is that with reinforcement learning, when we induce reasoning, when we instill reasoning via reinforcement learning, it is able to quote unquote think in a step by step manner, and it is able to identify the mistake it makes and able to correct those mistakes so that it can reach the correct answer. If it reaches the correct answer, it does get a reward, but if it does not get a correct answer, it does not get any reward. This reward plays a huge role in reinforcement learning, and in the coming lectures you are going to see why. Along with that, I am also going to show you this, the aha moment of reasoning LLMs. So let me show you this thing. So let me copy this image and put it here. Insert a slide. Yeah. So this is the first time the Seek team was able to identify that the LLM is actually using reinforcement learning to reason. So this this text that you are seeing is part of the DeepSeek V3 or V4 paper. I do not exactly remember, but it was the first time the world came to know that you can use reinforcement learning to instill reasoning in LLMs. I'm not exactly 100% sure it was the first time, but it was one of the major breakthrough for instilling reasoning into LLMs using reinforcement learning. So here, yeah, this is the part. So the LLM is trying to answer the given question, and in the middle, it has realized that the step it just did was wrong. If you are a math person, then you can see that the mistake it made here. And in between the response, it realized that it has made a mistake and then it started to correct the mistake it made. If you want to me to explain that what is the mistake that it is making here, I can explain you that as well. Because I am semi crazy when I'm learning things, so I actually learned that what was the mistake it was doing here. So yeah, it was an interesting aha moment of an intermediate version of DeepSeek R10. So sorry, these are the reasoning DeepSeeks. So DeepSeek R0 is actually the first effort of DeepSeek team uh, for these reasoning LLMs, but this R10 is the one that they actually no, sorry. The DeepSeek R10 was the first effort by the DeepSeek team to build a reasoning LLM, and while building it they came across this aha moment that became a aha moment both for the LLM and for us as well. So the model learns to rethink using an anthropomorphic tone. This is also an aha moment for us. They have written it as well, allowing us to witness the power and beauty of reinforcement learning. So yeah, this is the preamble. I think it is the correct word, but this is basically why do we use reinforcement learning for instilling reasoning into large language models. I hope you were able to understand. Thank you. See you in the next lecture.